Hello class, welcome to our next lecture, which is going to start talking about ions and isotopes, and also how to calculate the numbers of protons, neutrons, and electrons with ions and isotopes. So let's start by defining our important words. We have an isotope, which is an element having the same number of protons and a different number of neutrons. So we have some great examples here as carbon 13, cobalt 60, and hydrogen 3. So normally carbon has an atomic weight of 12, but anytime it is written as the number it's not normally, so carbon's normally 12, we call it carbon 13 is the name of the isotope, telling us that it weighs 13 atomic mass units instead of 12. Cobalt, same thing, it weighs 60. And then hydrogen normally weighs 2 atomic mass units, but it actually weighs 3 in this isotope. So anytime our isotope is different, or I should say anytime we have an isotope, we have a different number of neutrons than we usually do. Our number of protons stay the same, because if we change the number of protons, we are actually changing the element. So let's talk about the definition of an ion. An ion is an electrically charged atom created by a gain or loss of electrons. And our examples are cadmium 2+ and aluminum 3+. So the way an atom works is it's created when it shares or when it gives up electrons. So for example, cadmium has a 2+ next to it. So we have to remember that our electrons are negatively charged. So if we give up 2 electrons, if we lose 2 electrons from our normally neutral atom, we are actually gaining 2 pluses. It's almost like adding negative numbers together. So if we were to gain electrons, we would be getting a more negative number here, but we're losing electrons. So losing electron means that we're losing negative charge, which results in a positive charge. And the same thing happens for aluminum. So in both these cases, they are actually losing electrons. But let's see how this would work with calculating numbers. So the number next to the element is always its atomic weight, just like we talked about. So carbon 13 weighs 13 atomic mass units. It normally weighs 12 and normally has 6 neutrons. So how many more neutrons does carbon 13 have than normal carbon? And our answer is it just has 1 more, so it has a total of 7 neutrons, because our atomic mass is equal to our number of neutrons plus our number of protons. Since carbon is number 6 on the periodic table, we know that it must have 7 neutrons then. This is also a very important note that carbon in this isotope will still have the same number of protons and electrons. If we change the number of protons, we're changing our element. If we change the number of electrons, we're creating an ion on top of an isotope, which is incredibly rare. So we usually only see isotopes or ions, but not both. So we can only change the number of neutrons or the number of electrons. So how does this work with an ion? So the number next to the ion tells how many electrons have been gained or lost. Like we mentioned with our examples, aluminum 3+ has lost 3 electrons, not gained 3, because electrons carry a negative charge. Another great example that we talked about was cadmium 2+. So cadmium has lost 2 electrons. So the number of protons in cadmium, looking over at our little element, we can see 48 is our number. We can see that the entire weight is 112.4, which I rounded to 112 for this example. And then if we do 112 minus 48, we can get 64. So the answer to our difference problem is 64. And then our electrons. So our protons and neutrons are calculated just the same way for ions as we have before. Our electrons, on the other hand, usually match our number of protons. But since we have cadmium 2+, we know that we have lost 2 electrons. So we are usually at 48, but we are at 46 total for this example. So here's our periodic table. I like to put it in every presentation just at the end, as we're going to be starting to work through some problems. I will post another video along with this to show us some more examples and how to work through some of our homework problems.